Let's look at another example. Find the inverse function of this, it's called rational function. So nothing's really going to change. First step is to solve for x. So I'm going to write this out, and notice what I'm picking these examples so you can put them side by side and start to realize that the steps are identical each time. And look at very carefully at each process. Study that, and then you start realizing that the maneuver to solve anything is pretty much the same all the way across. Okay, so I'm going to move or subtract 4 from both sides. So again, I'm trying to solve for x, so I need to isolate this term right here. So subtract 4 from both sides and get the following. Notice that because it's a fraction, I'm really trying to be careful to create more space between the lines. Otherwise, it gets to looking disastrous. So I'm hoping that space is large enough so I don't get confused. Now, at this point, I need to, just like in the previous, I had the square root, I need to get rid of the variable from the denominator. So when you have these rationals, that getting rid of the denominator is the key when there's a variable there. Once it's on top in the numerator, I can maneuver it better. So I'm going to multiply both sides by 2x minus y just to accomplish this. So now I am going to write the steps out because I want to make sure you understand what I am doing. And you've got to be careful here. So multiply these two. The same expression divided by the same expression is a 1. So x here. And now it's going to get interesting. The a that I finished, that I solved, no, there's another x here. So I need to extract this x from this side and move it to the other side. But to do that, I need to mix it up first, unfortunately. So I'm going to distribute all this and see what I get out. There's no other way. X is now trapped inside these parentheses. So distributing is the only way to get it back out. So 2x y, 2x times 4. Is that right? Is that right? Yes. 2x times 4, so it's negative 4, negative 8x. Negative 5 times y. And negative 5 times negative 4. 20. All right. So now it looks like really it does not look nice at all. What should I do? I mean, I have this x, I can't, they're not like terms. This looks hopeless. So what we're going to do is the following. We're going to bring all the x's back to one side, right? The variable we're solving for has to go back to the other side. So I'm going to subtract 2xy from both sides, add 8x from both sides. So this stays alone. So let me do it again. Subtract 2xy from both sides. Add 8x to both sides. Then when I do that, these add up to 0, subtract to 0. I have this. And again, it goes, boy, this doesn't even look any better. How are we going to get out of it? I can't actually add, well, I can actually. 8 plus 1x plus 8x is 9x. Hey, that's nice. But now what? I can add 9 and the 2 so that they're not like terms. I got 2xy, not just x. So the next maneuver is to create one instance of x, and the only way to do that now, if you can get away with it, is factor. So I'm going to factor x from both sides. Because if distributing create multiple instances of something, factoring does the exact, and they have x as a common factor. As soon as I do that, I have one instance, and now I can finish solving for x. Divide both sides by 9 minus 2y. I have found the inverse function. So again, I'm going to just do this, f inverse of y. Just do that. Fantastic. So now I have done it. Let's find now the domain of f of x. So the domain of f of x, again, the only issue I see here, again, the all real numbers, the numerator, the 4 does absolutely nothing, does not take in a variable. The denominator here, and it cannot be 0. So again, all we need to do is figure out what causes that denominator to become 0. Add 5 to both sides, divide by 2, and bingo. I have 5 halves, so again, domain just cannot include 5 halves. So the domain of f of x, pretty straightforward. It's everything else except the problem. So domain x is, and again, negative infinity to 5 halves, and then union with 5 halves going to infinity. So again, I'm excluding the only point is 5 halves. That's everything else is fine. Okay. Now, great. Now, what is the range of f of x? Well, again, the range of f of x is the domain of this one. And again, that was pretty simple, finding the domain of this function, and this is of the same type. Notice this is 1, 2, 1. So therefore, finding the domain is going to be pretty straightforward for either one. The square root, on the other hand, when we found the inverse, we were also met up with a quadratic. Well, a quadratic is not 1 to 1. So all of a sudden, I had to really think about what am I going to do? It's not 1 to 1. And notice I went back to a function that was 1 to 1 in order to figure out what the range was. But this is not the case here. This is going to be way more straightforward. So now the domain, the range of f of x will be the domain of this function. So now I'm going to find domain of f inverse of y. Okay. So the numerator is all real numbers. The denominator is all real numbers. Great. So the only issue is the denominator cannot be a 0. So I just need to figure out what that is. Add 2y to both sides. Divide by 2. So it looks like a 4.5. So now that is the domain of f inverse, but that's not what I was after. Sorry, this is not the domain. This is the thing I cannot have. So what I found is y cannot equal -1/2, but everything else is good to go. So now I can finish this off. Range of f of x is, again, notice that f of x, the range is, I'm talking about y's. And notice that's why I'm not changing x and y, so you can see that I am talking about y's. This question is about y's. So looks like all the y's can be everything except 9 pounds. So come over here. So again, all textbooks at this point switch the x and the y. I find that I'm pulling my hair when I'm trying to teach this because there's two things going on. It serves no purpose except to make it look like you think it should look. But other than that, yeah, it starts to create havoc. But if you leave it alone, then all of a sudden things line up beautifully.